Okay, today we're going to go over section 6.4, differences of squares. So this is going to be like a shortcut of how to factor problems that look like this: a squared plus b squared. All we're going to do is basically take the square root of a and take the square root of b, and then you split it up. A goes at the beginning of both of them. B goes at the end of both of them once you take the square root, and one's a plus, one's a minus. Or you can flip-flop it, do the other way. So first, let's make a list of perfect squares. Perfect square is anything that when you take the square root, gives you a whole number. So 1 would be a perfect square. 4 would be a perfect square because the square root would be 2. 9, 16, 25, 36, 49, 81, 100, 121, 144, 169, 196, and 225. These are all perfect squares up to 15. So the square root of 225 gives you 15. Okay. If you don't have these memorized, that's okay. You can just plug them in your calculator. So let's go through. Let's look at example number 1. It says factor if possible. If not, write prime. So we look at n squared, and we're going to take the square root of it, and that squared and the square root cancel each other. You're left with n. Take the square root of 49, and if you remember, square root of 49, if not, plug it in your calculator, you get 7. So then you're ready to write your answer. 2 parentheses. N goes at the beginning of both of them. 7 goes at the end. One's a plus, one's a minus. Okay, number 2, same idea. Square root of 4n squared. Well, the square root of 4 is 2, and the square root of that n squared is just n. Then take the square root of 25. You should get 5. You're ready to write your answer. 2 parentheses, 2n at the beginning, 5 at the end. One's a plus, one's a minus. Okay, number 3, take the square root of 36m squared. The square root of 36 is 6. M squared would be m. The square root of 1 is just 1. So 2 parentheses, 6m, 1, and again, one's a plus, one's a minus. Okay, number 4, here's where we get one of these that's not possible. It has to be subtraction. All of these are subtraction. Up here it says subtraction. If it is a plus, then you cannot factor it. So not factorable. So what we do is we call it prime. And you're done. That's it. Okay. All of these here at the bottom, if you look at the numbers, these are not perfect squares. So you have to see if maybe you could factor something out first. Basically, you're trying to find the GCF. Okay. So the GCF for this first one, what number goes into both of these? 6. So I'm going to divide them both by 6. I'm going to write my GCF first. The 6's cancel. I'm left with n squared, which is a perfect square, minus 54 divided by 6 is 9, and 9 is a perfect square. Now you can do the differences of squares. So the square root of n squared is n. The square root of 9 is 3. You bring down that 6, and then you write your 2 parentheses. N plus 3 and n minus 3. Okay, next one. Find that GCF first. So what goes into both of those numbers? 3 does. So I'm going to divide both by 3 and see if I'm left with perfect squares. So 3 goes first. 3's cancel. C squared, which is a perfect square, minus. Divide, you get 4, and that's also a perfect square. Square root of c squared is c. The square root of 4 is 2. So you're ready to write your answer. Bring down the 3. C plus 2, C minus 2. Last problem. Find that GCF. The number that goes into both those is a 2, and they both have a p. So we're going to factor out a 2p. So divide by 2p. That goes first. 8 divided by 2 is 4. If you subtract these p's, you're left with p squared. That's a perfect square. Minus, the p's cancel, divide, you get 25. That's also a perfect square. So the square root of 4p squared is 2p. The square root of 25 is 5. You're ready to write your answer. Bring down 2p, parentheses, 2p plus 5, 2p minus 5. So if you look at the numbers and they're not perfect squares, see if you can factor out a GCF first.